Well, happy Easter, everyone. I hope it's as a joyful holiday for you as it is for me. And in fact, it's about to get a lot more better for y'all because look what the Easter Bunny left for all of my students. I woke up this morning and outside of my door, I found this. It says, to Mr. Russell's students from Easter Bunny. Well, isn't that sweet? Yeah, what a considerate make-believe animal that he would come and deliver an Easter egg to you. Well, I bet you all are wondering what's inside of it. Well, let's. I'm wondering that too. So let's see what he left. Looks like some kind of paper. Let's open it up and see what it is. Oh, well, look at that. The Easter Bunny left you all 6 pages of the test review to do over Easter break. Well, look at that. Look, we have problems 1 through 20. All 1, 2, 3, 4, 5, 6 pages of the review sheet. Oh, well, what a thankful... And look, he even wrote Happy Easter across the front. Well, isn't that something else? What a truly, truly great day it is to do some math! All right. Well, let's get started here. This won't take too long because we have persevered and labored through our quadratic unit. So let's get started. Turn on pen, okay? Number 1, what are the roots of the following quadratic function? It's important to remember that roots can also be called solutions, and they can also be called zeros. And we find roots and zeros by inspecting where the parabola intersects the x-axis, because it's at this value where y, well, I don't want to write it there, that's confusing. Here's the x-axis, here's the y-axis, and it's at these 2 points where our y value equals 0. So in this particular instance, it looks like our roots are -1, because we see that we go over -1 on the x-axis, and we go over 1, 2, 3 on the x-axis. So it's where x equals -1, 0. And in fact, we don't even need this x. I'll just write -1, 0 and 3, 0. So those are the 2 solutions where our parabola intersects the x-axis right here. Very good. Graph the function -x squared plus 5. Okay. Well, let's see how we do that. We know that this negative here will make our parabola concave down, so it'll look like that, and we know that our plus 5 will shift our parabola up on the y-axis 1, 2, 3, 4, 5 spots. So let's do that. 1, 2, 3, 4, 5. So there's the vertex of our parabola, and we know it's going to open downward. And we also studied the general pattern of what parabolas look like. We go over 1, down 1. It's symmetrical. We'll go over 2, down 4, because 2 squared is 4. We can do the same thing on the other side. And if we want to, we can go over 3, down 9. 4, 5, 6, 7, 8, 9. There's our parabola right there. And then we'll go ahead and graph it. Nice and easy. Oop, a little bumpy there. And there's our beautiful parabola right there. This is y equals -x squared plus 5. There you go, and there's our parabola. Look how nicely I labeled the points for Mr. Russell, so he knows that I know what points actually lay on the parabola, and therefore he can give me full credit for this type of problem when it appears on the test. Number 3. Let's keep moving along here. Describe the parameter changes for the equation y equals -3x squared plus 7 when compared to the function y equals x squared. Okay, Well, let's see first of all what the difference is on the calculator. Is there a way I can lock my window?